mass number is equal to number of protons plus number of neutrons. So the question had 8 protons plus 7 neutrons, meaning the mass number is 15. So the answer is 15. Okay, that's okay. So now we have another example here. We have another example here. The mass number of your writing, the mass number of an element, the mass number of an element P. The mass number of an element P is 24. Its atomic number, and its atomic number is 12. Find the number of neutrons. Find the number of neutrons. Tell me the answer. Yeah, people are getting 12. And people are getting 12. So we say that mass number is equal to atomic number or number, because atomic number is the same as number of protons. Atomic number plus number of. Oh, someone's writing the screen. That's very bad. So this is the formula I gave you. Mass number is equal to atomic number. So atomic number, we explained that atomic number is the number of neutrons, the number of protons in the nucleus of an atom, then plus the number of neutrons. So in the question, they have given us the mass number is 24, is equal to atomic number, they have given us 12, then plus number of neutrons, then we call it n. So when you take 12 on this side, you're going to get 24 minus 12 is equal to n. So 12 minus 24 minus 12, you're getting 12 is equal to n. So meaning the number of neutrons is 0. That's very good. That is very good. So the answer is 12. The answer is 12. Now the mass number of an element, sometimes you don't need to use this letter. And this letter on top, P, represents the atomic number or the mass number. In this number A down represents the atomic number. So if I say, yes, go on.
Are those letters constant, as you've talked about? They normally use them to refer to the mass number and atomic number, because for us they told us that the mass number is A and then atomic number, we take it as Z.
No, they are not constant. They are not constant. Someone can use other letters.
Okay.
Someone can use other letters. So now, these letters, they are on a periodic table. I don't know if I've covered the periodic table. The periodic table looks like this. And this is the periodic table. This is how it looks. This is the periodic table. So these ones, 1, 2, 3, 4, 5, 6. Now these are the atomic numbers. These ones which go in order. Now this case we never wrote the atomic masses. Now when we are designing this periodic table, we follow the atomic number. Okay, we follow the number of protons. The element which had the least number of protons came first, and that element was hydrogen. It had only one. It had only one electron, followed by had only one proton, followed by helium, followed by lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, like that. So currently we have more than 120 elements in the periodic table. So I was emphasizing something on atomic number and mass number. So I can use any letter. I can use Z. So if this is B, this is A, the number up is the mass number. The number up is the mass number. Then the number down is the atomic number. Now, given an element, Z with this number up as 40 and this number down as 20. Find the number of neutrons. You give me that answer, you do it. You read the answer there. So people are getting 20. Like I said, that mass number is equal to atomic number plus number of neutrons. So in this case, 40 is the mass number, and the 20 is the atomic number. So to get the number of neutrons, we're going to get 40 minus 20. When you get 40 minus 20, you're going to get 20. So these are the number of neutrons. The number of neutrons. Now, I want to talk about electrons. You write this note here. This note is saying that the number of photons is equal to the number of electrons. In an atom. And you know, this is very important. Always the number of protons are equal to the number of electrons in an atom. Of course, an atom is neutral. There's no need of adding the word neutral. An atom is always neutral. It's always neutral. So in an atom, the number of protons are always equal to the number of electrons. They're always equal to the number of electrons. So that's very important. I hope you finished noting that. That's very important. Now, I wanted to also talk about electronic configuration before we go to bonding. Electronic configuration. Electronic configuration. Now, as you hear the word electronic configuration means arranging those electrons on the energy levels or energy shells of an atom. How those electrons are arranged. Like I said previously that an atom has gotten the nucleus. The nucleus has protons and neutrons. Then it has gotten also what we call energy levels or energy shells. Now the electrons, they are found on energy shells. The electrons are found on energy shells. Now the size of an atom is determined by the number of electrons on the energy shells. So when we talk about electronic configuration, we are meaning the arrangement. We are meaning the arrangement of electrons. Arrangement of electrons. On the energy levels. On the energy levels of an atom. Energy levels of an atom. So that is the electronic configuration. Now, when you're writing electronic configuration, I will use the number of electrons. Like I said, the number of protons is equal to the number of electrons. This note is very important. A number of protons are equal to the number of electrons in an atom. They are equal. They are equal. They are equal to the number of electrons. The number of protons are equal to the number of electrons. So when you are writing the electron configuration, we consider the number of electrons in the nucleus of an atom. Now there is one thing you need to note, that in the nucleus, in an atom, yes, Ruth. Ruth, go on.
In the chat, there was a concern raised by someone who calls himself iPhone. They're asking, how is it different from electronic structure?
Now, electronic structure is what I'm explaining right now. How those electrons are arranged. Now, electron configuration is written in this form, is written in numbers, like this. You can write like this. This is the electronic configuration, 2 to 8 to 2. Now, let me first explain this. I'm going to explain. Now, in the nucleus, in an atom, we have the nucleus. This is the nucleus. Now, this nucleus is surrounded by energy levels. These are called energy levels. So the number of energy levels determine the size of an atom. So this is an atom. Now the inner shell takes a maximum of 2 electrons. The inner shell, leave alone the nucleus. This is the nucleus. You think about the inner, this immediate shell that surrounds the nucleus. It takes a maximum of 2 electrons. Then the second shell after this takes the rest take a maximum of 8. The rest take a maximum of 8 electrons. When I say maximum, it means it can take a 6, can take 4, it can take 2, it can take 1, but the maximum should be 8. So the rest of the shells, they take a maximum of 8. So, but in O level, consider the first 20 elements. The first 20 elements. So you'll cover that one. You'll cover other elements when you continue with the subject, and you'll be locating those electrons on orbitals. Call them orbitals. Have different types of orbitals. You cover them. What you call the orbitals. Now I wanted to emphasize something. I wanted to emphasize something that if given an element, you can write this example here. You can write it down. Write this example down. I'm given an element with atomic number 19. Then the question is saying, draw its electronic structure. Draw its electronic structure. Then question number 2 is saying, write its electron configuration. So first copy that question. I give you 1 minute. I hope you are done. The question is saying, given an element with atomic number 19, draw its electronic structure. Then part B is saying, write its electronic configuration. Now, I've explained this. I've explained the number of protons. A number of protons, they are always equal to the number of electrons. Number of protons is equal to the number of electrons. So if an atom has 19 protons, it means it has 19 electrons. It means it has 19 electrons. So we use electron to draw an electronic structure, also to write the electronic configuration. So when you're rotating this electron, you say that the inner shell, an atom has gotten the nucleus. An atom has gotten the nucleus. And if this is our nucleus, I've gotten the inner shell, then we'll say the inner shell takes a maximum of 2 electrons. So if I write 2 here, I distribute 2 electrons, means out of 19, I'm remaining with 17. So at the second shell, takes a maximum of 8 electrons. So it means I'm going to write 8 electrons here. So these are 8 electrons. So 8 electrons plus 2, it means 10 electrons. So 10 electrons minus 9 means I'm remaining with 9 electrons. So I draw another shell because I said every shell takes a maximum of 8. Apart from the inner shell takes a maximum of 2. Then the rest of the shells take a maximum of 8. So the next shell is going to take a maximum of 8. So I'm going to distribute this. So we have 2 inside, then plus 8, that is 10 plus 8, that is 18. So it means that you are remaining with 1 electron. So you draw another shell. Don't force it on the third shell, because said that every shell takes a maximum of 8 apart from the first one, which takes a maximum of 2. So it means that the other electron, you're going to write it on the last shell. So this is the electronic structure of that element. So when you're writing the electron configuration, you just count the number of electrons in each shell. You start with the inner shell. The inner shell had a maximum of 2. So you write 2. Then 2. Then this one had a maximum of, the second one had a maximum of 8. Then the third one had a maximum of 8. Then the last one had the 1 electron. So this is the electronic configuration of that element. This is the electronic structure of that element. Hope you've understood the difference. Hope you've understood the difference between the electronic structure and electronic configuration. Hope you finished taking note of something of what you want to take note of. So let me write this one. This simple exam. Okay, write this. You do this activity. You do the activity, then tell me the answer. You do the activity. Yeah, write the question, then you answer it. So some people, I'm seeing some people getting 2 to 8 to 3. Other people are getting 2 to 8 to 4. So like I said, like when you're writing electron configuration, you consider the number of electrons. At the number of electrons, they're equal to the number of protons. So it means you have to first get the number of protons. And the number of protons, they're equal to the atomic number. So I'll use this formula. I'll use this formula which says that a mass number is equal to atomic number or number of protons, then plus number of neutrons. Or number of neutrons. So the mass number we are given 27 is equal. We are looking for the atomic number, then plus the number of neutrons we are given 14. So it means our A is going to be 27 minus 14. So 27 minus 14, we are going to get 13. So this is the atomic number. And you said atomic number is the number of protons. Then also we say that the number of protons is equal to the number of electrons. So it means this atom has 13 electrons. Means this that atom has 13 electrons. So when you try to draw its electronic structure, and if take this one to draw a nucleus, so it has 13 electrons. So the inner shell takes a maximum of 2. When it takes a maximum of 2, it means the other shell is going to take 8. 1, 2, 3, 4, 5, 6, 7, 8. So when you add the 2 plus 8, that is 10. So you're remaining with 3. This is 1, 2. Okay. So the electron configuration, when you're writing it, start from inside. It has 2 electrons, then 2. These are 8. These are 8 electrons, then 2 to 3 electrons. So this is the electron configuration of that element. We don't consider the number of neutrons. Those who got 14, you consider the number of neutrons. So when you're writing the electron configuration, you consider the number of electrons, not the number of neutrons. So I want to talk about the stable configuration, the stable electron configuration. And a stable electron configuration. Now the stable electron configuration, now we have 2 to 8, and 2 to 8. Now when you consider the periodic table, we have this is the example of the periodic table. Now when you consider the periodic table, we have these elements here. These ones are called group 8 elements. Now helium, this He is called helium. It has atomic number of 2, as you can see from the table. Then you have neon. Neon has atomic number of 10. Then you have argon. Sorry, this is Ar. Egg is silver. This one, egg is silver. So argon is Ar. Its atomic number is 18. So when you try to write their electron configuration, when you try to write their electron configuration, you will say that helium has 2. Then neon has atomic number of 10. Then argon has atomic number of 18. So for helium, if this is the nucleus, takes a maximum of 2. So it means its electron configuration is going to be 2. Now someone is raising up. Let us first listen from her. Just go on.
So you're saying group 8, but you're saying on a predictable you're saying group 18. So what's that?
Okay. So now I'm going to explain that. So let me first explain this. That neon has the atomic number of 2. It means the inner electrons, the inner shell takes a maximum of 2. Then when we talk about neon, has 10. It means the inner shell takes a maximum of 2. Then means we are remaining with 8. So it means its electron configuration is going to be 2 to 8. Then when we talk about argon, its inner shell takes a maximum of 2. Then the next shell takes a maximum of 8. Then the next shell takes a maximum of 8. Yes, Ruth.
I don't know why, but I fail to understand when we come to this point of looking at stable atoms and then the ions leading to ion formation. So what, I don't know, I think I even asked this question the last lesson we had. Do the properties change? I don't know if I got the answer right the other time, because now that these electrons are exchanged, or they're being transferred, do the properties, what happens to the properties of the ions now? Do they become similar to the ones of the noble gases?
Yeah, okay, I'm going to explain that way. Yes, Rama, yes, your hand is still up.
So this thing is about bonding. Explain quantitatively why metals acquire positive charge after losing electrons and non-metals acquire negative charges after gaining electrons.
Okay, I'm going to explain that. Someone was asking. Is this one? Is it taking off? You ask. Unmute and ask. You ask. Yeah, yes, a question.
How do we find the atomic number?
How do we find the atomic number? And also someone was asking in the question in the chat, when elements become charged, they remain elements or they become compound. Okay, I'm going to explain that. So when you try to write electronic configuration, it's going to become a 2 to 8 to 8. Now these are called the stable configurations as per now. As per now, those are the stable configurations we have. How 2 to 8 and 2 to 8 to 8. Those are the stable configuration. Now these elements, as they try to react, they tend to achieve the stable configuration of the noble gases. They tend to achieve the stable configuration of the noble gases. So these are called the noble gases, the group 8 elements. So someone asked why the other periodic table has 18. Okay, for them when they are labeling those that periodic table, they just counted the number of columns. They just counted the number of columns. Like this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So for them, they just counted the number of columns. But the periodic table has gotten, someone's writing in the screen. Can you imagine? That's very bad. Don't write in the screen. So the periodic table has gotten the periodic table has gotten we have these long columns. We have this one, then this one, this one, this one, this one, this one, this one, and this one. Those are the long columns. You consider those long columns. So this is 1, 2, this is 3, 4, 5, 6, 7, 8. So the periodic table has 8, we call them groups. These ones, we call them groups. So there are 80 groups. Yeah, there are 80 groups. Leave around the other columns, because when these ones are drawing the periodic table, they just consider the number, they just count the number of columns, but have groups. So now this one, the last one, is called group 8. Group 8 elements, they are called noble gases. They are called noble gases or inert gases. Now they are called inert because their valence is 0. They don't have, their valence is 0. They can't react. They have the stable configuration. When we talk about stable configuration, hope I've explained this. This is 2. Then I also have 2 to 8. Then also have 2 to 8. That's why you've never had a compound, maybe helium carbonate. They are not there because this one they can't react. We never heard of any compound called argon, maybe argon sulfate. You can't find them. They can't be there. They can't be there. Maybe neon oxide. You can't find them because they can't react. They can't lose or gain electron or even sharing. So when these elements are reacting, they strive hard to gain the configuration of these noble gases. So we have then someone was asking about elements, metals, as why they lose electrons and they form a positive charge. Then the anions, when the nonmetals, when they react, they form a negative charge. So I want to explain that. I was explaining ions. Now we're reaching ions. Now these ions, they are formed when you pass electric charge through an atom. When you pass electric charge through an atom, that atom is either going to gain electrons or it's going to lose electrons. So, for example, if I consider an element like aluminium, and this is the chemical formula for aluminium. Aluminium has atomic number of 13. Aluminium has atomic number of 13. So when you try to write its electron configuration, is going to be a 2 to 8 to 3. It is going to be 2 to 8 to 3. Then also you have nanometals. Maybe we can talk about sulfur. Sulfur, its formula is S, has atomic number of 16. So when its electron configuration is going to be 2 to 8, 2 to 8 to 6, 2 to 8 to 6. So when you pass electric charge through these atoms, some of them will just gain electrons, others will just lose what? Electrons. Now, how do you know that an element is going to lose electrons, then the other element is going to gain electrons? Now, you get to know that when you get, when, for example, you write the electron configuration, maybe 2 to 1, you have 2 to 1, maybe 2 to 8 to 2, maybe also when you have 2 to 8 and 3. Then also have nanometals. I have electron configuration ending in this form, maybe 2 to 5, 2 to 8 to 5, or I can say 6, 2 to 8 to 6. Then I can also write 2 to 8 to 7. Now all these elements, they are striving to get the stable configuration of 2 and 2 to 8, and also 2 to 8 to 8. So when you pass electric charge through these elements, they are going to gain this stable configuration of the noble gases. Some of them are going to gain, others are going to lose. Now these elements ending in 1, 2, and 3, they easily lose because it is very easy to lose these electrons to gain a stable configuration than gaining, because when it is to gain, it has to gain 5 electrons and to form a stable configuration of 2 to 8 to 8. This one, if we consider this one is to gain 5 electrons. So gaining 5, losing 3 electrons is easier than gaining 5 electrons. So that's why these elements here ending in 1, 2, and 3, they just lose these electrons because it's very easy to lose those electrons than gaining. Now these elements here, these electrons here, it becomes very hard to lose all these electrons. So what they do, they just easily gain those electrons. They just easily gain those electrons. So these elements which easily lose electrons, which just lose electrons, these ones ending in 1, 2, and 3, they are referred to as metals. they are referred to as metals. Then these ones which end in 2 to 5. Now someone wants to ask what of 4. I'll explain that. Then 2 to 8, maybe to 7. Now these ones ending in 5, 6, and 7, they are called nanometals. These ones are nanometals. They are called nanometals. Nanometals. Now, when you try to look at this, you have group 1, group 2, and group 3. Group 1, group 2, and group 3. We have these elements here. This 1, 2, and 3. Now, these ones, they are called the metals. Elements which fall under these groups here, they are metals. Then from 5 to 6, no, from 5 to 7, they are called nanometals. These ones are nanometals. Then what of 14? Now these 14, they have both characters of metals and nanometals, but the metallic character increases as you go down the group. So carbon, when you look at carbon, is on top, then lead is down. So you'll notice that carbon is a nanometal. That's why it combines the other elements covalently. Then lead is a metal. So the metallic character increases as you go down the group. Then I want to talk about the charge. The charge, for example, if an element is has atomic number of 3. If an element has atomic number of 3, its electron configuration is going to be at 2 to 1. So when this element is achieving a stable configuration, it is going to just lose. So if that element, maybe it is P, it is going to lose 1 electron. If it loses this 1 electron, it is going to achieve a stable configuration of 2. So I'm going to write P. Now when it loses 1 electron, it gains a positive charge. Now this positive charge means that an element is lacking some electrons. It is electron deficient. When I put a positive charge, sometimes say electrophilic. It means it is lacking some electrons. So the chemistry term meaning that is called electrophilic, meaning it lacks some electrons. That's why we indicate it with a positive charge. Now this element, after gaining a positive charge, its electron configuration is going to change. It is not now 2 to 1. Now it is what? It is 2. It has gained a stable configuration of the inert gases, which is 2. I hope that is clear. Let me give you another example here. So if we consider an element, Z with atomic number, let me say, let me use 7. With atomic number 7, it means its electron configuration is going to be 2 to 5. is going to be 2 to 5. So it means this element, to achieve a stable configuration, has, because I talked about losing and gaining. Now these electrons, when they are ending in 1 to 3, they are just lost because it is very easy to lose these electrons. Then from 5 to 7, this one they just gain. So it means this element, to gain a stable configuration of 2 to 8, because these are the stable configuration we have, it is going to gain 3 electrons. So it's going to become, now gaining, when they gain, we attach a negative charge on that element. So in this case, yeah, I'm going to write the negative here. But how many electrons have been gained? There are 3 electrons, so I'm going to write 3 with a negative, meaning that this element has gained 3 electrons. Now this negative charge, it means that this element, it means that this element has excess electrons, has more electrons, and that the chemistry term used to refer that is nucleophilic. Nucleophilic, meaning it has more electrons. If it has less electrons, means it is electrophilic. So that's why we attach negative charges and positive charges on these elements. So if I write, for example, let me consider magnesium. Now magnesium has atomic number of 12. So it means its electron configuration is 2 to 8 to 2. Now this magnesium, to gain other electrons is going to be hard because it's ending with 2. It is very easy to lose those 2 electrons when you pass electric current into that atom. So this magnesium is going to lose 2 electrons. So when it loses those 2 electrons, it's going to, because losing, I said we attach a positive charge. We attach a positive charge on that element when it has lost it. So it's going to be magnesium plus. But how many electrons have been lost there too? So you write 2 here. So it's going to be magnesium with a positive charge of 2. Now its electron configuration is no longer 2 to 8 to 8. Now it is 2 to 8, meaning it is electron deficient. It lacks some electrons. So hope you've heard about the word valence. Now the valence of an atom, of an element, these are the electrons which are lost. These are electrons which are lost. So the valence of this magnesium is 2 because it has lost 2 electrons. So let me talk about another example maybe. Yes, go on.
If I'm going, taking you a little behind from what we learned in the previous lesson, but you talked about ionic bonding and covalent bonding, and you said when the force of attraction is strong, it is called ionic bond, an ionic bond, and then when the force of attraction is weak, such a bond is called a covalent. And then when you continue to I don't know how you can explain what the statement means when we talk about forces of attraction which are weak, because research has it that covalent bonding occurs when pairs of electrons are shared by atoms. Okay, I can understand ionic bonding because it's the basic type of bonding, but when it comes to covalent bonding, where they talk about bonding of a pair of electrons, I get confused.
Okay, thanks for that question. Then Rama.
So I was like, the ionic bonding is only metals and non-metals, and that magnesium that has lost to electrons, is it now a stable? Is it now a noble gas? Because it also has a stable configuration.
Okay, that one becomes an ion. That one becomes an ion. It's not a noble gas, but it has attained the stable configuration of noble gas. It is not a noble gas now, but as the stable configuration of the noble gas. That's fine. Rama,
Yeah.
you are lost. Okay. So from that, I explained ionic bonding. That I used an example of sodium chloride. You have sodium and chlorine. Now sodium has atomic number of 11, then chlorine has atomic number of 17. So when you try to look at the electron configuration of sodium, is going to be 2 to 8 to 1. Then chlorine is going to be 2 to 8 to 7. 2 to 8 to 7. Now to gain a stable configuration, this one is going to just lose what? 1 electron. Whereas the chloride ion or the chlorine atom, it needs only 1 electron to form what? A stable configuration. So when they are bonding, this 1 electron is given to what? And to the chlorine atom with 7 electrons on the outermost shell. So at the end, this one is going to remain with 2 to 8. Whereas this one is going to remain, it's going to gain 1 electron and becomes 2 to 8. 2 to 8 to 8. So this is a stable. So at the end, we are all getting a stable configuration. Then I also looked at another example of magnesium oxide. Now magnesium has atomic number of 12. Then oxygen has atomic number of 8. So this is magnesium is 2 to 8 to 2. Then oxygen is 2 to 6. So to form a stable configuration, this one just loses these 2 electrons, the magnesium. Whereas this one needs 2 electrons to form a stable configuration. So what they do, these 2 electrons, they are given to the oxygen atom, and this one becomes 2 to 8. Also this one becomes what? 2 to 8. So that is the ionic bonding. That's how ionic bonding occurs. Maybe lastly I can talk about aluminium chloride. Aluminium chloride. That's the formula of aluminium chloride. So when they are combining, we have aluminium and chlorine. So now aluminium has an atomic number of 13. Then chlorine has an atomic number of 17. So when you try to write its electron configuration, this one's going to be 2 to 8 to 3. Then this one is going to be 2 to 8 to 7. So this one needs to lose 3 electrons. So when it loses 1 electron, it's going to be 2 to 8. It's going to remain with 2 electrons. Then this one is going to gain that 1 electron, and it's going to be 2 to 8 to 8. So for aluminium to again react with chlorine, now this case chlorine is full. So it means it has to react with another chlorine. So what it does, it gets another chlorine with atomic with the electron concentration of 2 to 8 to 7. Also donates another electron. Then the other chlorine also becomes 2 to 8 to 8. So when it donates one electron, it's going to remain with 2 to 8 to 1. So what it does also gets another chlorine atom, and also what? It gives it that one electron. So at the end, it is going to remain as what? 2 to 8. So meaning that aluminium has reacted with the 3 atoms of what? Of chlorine. 3 atoms of chlorine. That's why you indicate what? That's why we indicate that 3. Now today I want to talk about a covalent bonding. Now covalent bonding is different from ionic bonding. Covalent bonding is sharing, the sharing of electrons. For example, if I have chlorine atom and another chlorine atom. Now the first chlorine atom has 2 to 8 to 7 because its atomic number is 17. Also another chlorine atom has 17. So it's going to be 2 to 8 to 7. So this is the atomic number of the first chlorine. This is the electron configuration of the first chlorine. This is the electron configuration of the second chlorine. Then what happens when they are bonding? Now when they are bonding, someone's writing in the screen, and that's very bad. This one needs 1 electron. Also this one needs 1 electron. But there is no element which is going to give those elements those electrons they need. So what is done is that they come to share. They come to share what they have, so that they form the stable configuration. So when I try to draw the first chlorine atom, the inner shell is if this is the nucleus, the inner shell is taking a maximum of 2. Then the next shell is taking a maximum of 8. Then the next shell is taking a maximum of, is going to take the remaining 7 because that's 17. So also the other shell has, if this is the nucleus, and the inner shell takes a maximum of 2, and then the next shell takes 8. Then the next shell takes 7. So this one is 2 to 8 to 7. Also this one is 2 to 8 to 7. Everything has gone. Everything has disappeared. That's very bad. So the outer shell, okay, let me just use the outer shell. The outer shell of the first chlorine has 7 electrons. I'm using the outer shell. Also the outer shell of this chlorine atom has 7 electrons. So since this is a 2 to 8 to 7, Also, this one is 2 to 8 to 7. So this one needs 1, also this one needs 1. So what they do, they come together and they share these electrons. So at the end, it is going to be like this. So they come together and they share. They come together and they share these electrons. So initially, this one had the 7. Initially, this one had the 7, also this one had the 7. So they come together and they combine. This one brings the other one which wasn't paired. Also this one brings the other one electron. And at the end, the outermost shell is going to be 4, 2 to 8 to 8. Also this one is going to form the stable configuration of 2 to 8 to 8. So they share these electrons which are not paired to form the stable configuration. So a covalent bonding is all about sharing. So identity bonding, the difference between identity bonding and covalent bonding is that covalent bonding involves this one involves a transfer of electrons. Hope you are noting something. A transfer of electrons. Transfer of electrons from one atom to another. From one atom to another and form a stable configuration. And this one mainly occurs in it occurs between metals and non-metals. Now the ionic bonding occurs between metals and non-metals. And now the metals, okay, like I said, ionic bonding involves transfer of electrons from one atom to another. So it occurs between metals and non-metals. Now the metals, these are the metals here. Group 1, group 2, then group 3. These are the metals. Then the non-metals start from group 5, group what? Group 7. So ionic bonding occurs between metals and non-metals. Then you have covalent bonding. Now covalent bonding involves sharing of electrons. This one involves sharing of electrons. Involves sharing of electrons between atoms, between 2 or more atoms. Between two or more atoms. So that's covalent bonding. And covalent bonding occurs between non-metals. Between non-metals only. And between non-metals only. between nonmetals only. So the type of bonding which occurs between metals only is called metallic bonding. I think shall cover that next time. So covalent bonding. Ruth has a question. Yes, Ruth, go on.
So what compound was formed? I'm asking that question together with Gideon. Is asking, is that a compound? Chlorine. If we have a covalent bonding acting on the two nonmetals, how do we call that compound? For example, that one which we used 2 chlorine atoms.
How is it called? Okay. They take the name of the bond. For example, you have ionic compounds and you have those covalent compounds. Now a chlorine. Now these elements you have a chlorine. Now sometimes we call them molecule. Now this one, it is having 2 atoms of chlorine combining. So when 2 atoms, 2 more atoms combine, they form a molecule. This is a molecule. Then you have oxygen. Oxygen is the same case. Now let me explain about the bonding in oxygen. Now the bonding in oxygen, there are 2 atoms of oxygen combining. Now oxygen, the first oxygen atom is 2 to 6. It has 8 atoms, 8 protons. Also the other oxygen atom is 2 to 6. So this one needs 2, also this one needs 2. As they are combining, if this is the nucleus, the inner shell is going to take 2. Then the other shell is going to take 6. Then also this oxygen atom is going to do the same. If this is the nucleus, the inner shell is going to take a maximum of 2. Then the other shell is going to take a maximum of 6. The remaining will be 6. So what do they do? Because this one needs 2, also this one needs 2. So this one, they come closer. This one, they combine. They come closer and they combine. So after the combination of those atoms, you're going to form something like this. We have the nucleus. And the inner shell has the 2. So this is the nucleus. So this one also has 2. So previously this one had 6. Also this one had 6. Now those 2 electrons were on this shell to make the 6. Also this one brings the other 2 electrons. Let me use here another color. So previously this one was 2 to 6. 1, 2, 3, 4, 5, 6. So it wasn't making the stable configuration of 8, 2 to 8. Also this one previously had 2 to 6. So what they do, they come closer. So as they come closer, they share these electrons. So when you count these electrons here, you are going to get this one, and you are going to get this one. This, you have this one, you have this. When you count 1, 2, when you count that, you're going to get, let me use this pen here. When you count, you're going to get 1, 2, 3, 4, 5, 6, 7, 8. Also, when you count this side, you're going to get 1, 2, 3, 4, 5, 6, 7, 8. So that's how they share those electrons. That's a covalent bond. So that's why, yeah, you'll never see oxygen atom written like this, oxygen alone like this. This is the oxygen atom. So oxygen is written as a diatomic, Diatomic means there are 2 atoms combining. So just they form the oxygen molecule. That's why you indicate the 2 down here, that there are 2 atoms of oxygen combining to form the what? Form the O2. That's why you put these 2 here down. Even chlorine, you write a 2 here. At form the what? The chlorine. Then nitrogen, that is the same case. Also, there are 2 atoms of nitrogen combining covalently and form nitrogen molecule, nitrogen gas. I hope that's clear. Hope that's clear. I take a screenshot of that exercise. You'll do it. I will do it in your free time. Arama has a question. Yes, go on. Take a screenshot. Rama, go on. Unmute and ask.
So I was asking that what are the definition for valence electrons?
Valence electrons, those are electrons that take part in the chemical bonding.
So it's only in chemical bonding.
The what?
So it's only in chemical bonding.
The valence electrons. Yeah, of course they're the one that
Actually,
What are you going to say?
I thought generally they are the electrons in the outermost shell of an atom.
Yes, yeah, those, yeah. Because even when you talk about bonding, you're looking at the outermost shell. Yeah, that's why I was considering the outermost shell.
Okay.
Yes, visible. Now take a screenshot of that exercise. You'll do it. This you ask your question. You unmute and ask. Rama, go on. Your hand is still up. Hope you finished taking a screenshot. Now, also, so you can take a screenshot of covalent bonding. You write your notes. You add on what you've been summarizing. So you can take a screenshot of the covalent bonding. Take a screenshot of that covalent bonding. Yeah, you will summarize your notes. Then now Shant is right. Every time he's writing the screen. Also, you can take that screenshot. You try to analyze it, and I haven't talked about methane gas. I think I'll talk about it next time. This is the chlorine. I've explained the chlorine when two atoms of chlorine bond with each other. Then also take a screenshot of this exercise. You'll do it. Take a screenshot of that exercise, you'll do it. Chlorine has, hydrogen has atomic number of 1. Then fluorine has 9. So this one is atomic number is 1. This one is 2 to 7. So for this one to gain a stable configuration, because I told you the stable configuration, you have 2 to 8, and also 2 to 8, and to 8. So this one needs 1, also this one needs 1. So what they do, they come together and share. Let me write it here. This one has atomic number of 1. And this one has atomic number of 9. So the electron configuration of this one is going to be 1, then this one is going to be 2 to 7. So when they are bonding, they come closer. This is hydrogen. If this is the nucleus of the hydrogen atom, it has 1 electron. Then if this is a fluorine, and this is the nucleus, the inner shell takes a maximum of 2. Then the other one takes 7. 1, 2, 3, 4, 5, 6, 7. So this one needs 1, also this one needs 1. So what they do, they come together and join. So after the combination, you are going to form something like this. If this is the nucleus of the hydrogen atom, and it is going to get the what? It's going to combine with the other of these electrons and outermost shell. So at the end, this one will be having 2 electrons, this one will be having 2 to 8. So this is the electron configuration. So that's the covalent bonding. That's how they do share. So this is the, hope you take the screenshot, take that screenshot. Take that screenshot. So the question is saying what type of chemical bond would you expect in hydrogen fluoride? Because there is sharing, you are going to write covalent. There is no N, the word is covalent. Covalent bonding. Then you do that diagram, the electronic structure of those atoms combining. So let us stop here. Now, if you have a question, you can ask. Let us stop there. Let's stop there. Let us stop there. So if you have a question, you can ask. Let us have a closing prayer from someone who will give us. Let us have someone to give us a closing prayer, then call it a day. Raise up your hand and give us a closing prayer. You don't want to be that in a closing prayer. Yes, Ruth. Ruth, you unmute.
Okay, let's humble ourselves and we.
Ruth, unmute.
Let's humble ourselves and we pray. Father Lord, we thank you so much for this lesson. We thank you for this day that you have enabled us to live. Father, we are grateful for the gift of life and this great opportunity, King of Glory, that we have been able to learn and recall whatever we learned in our previous in our previous lessons with our teachers at school. We ask that you may continue to guide us, Father Lord, and bless us. Continue to bless our teachers. May you continue to enlarge their territories and move with them. May you go before us in everything that you're going to do. We give you all the praise and all the honor. For in Jesus' name I prayed. Amen.
Amen.
Thank you very much for that.
You're welcome. Thank you, sir. Thank you so much. I read that. Thank you very much. Bye bye, guys.